In this video, we'll take a look at notes for section 1.1, which is functions and function notation. So our definitions. First definition is, what is a relation? A relation is a set of ordered pairs. So when you think about any type of graph, a circle, a line, a parabola, those are all relations. They're all sets of ordered pairs. Even if you just have a set of ordered pairs with 10 values in it. The set of all first values or inputs is called the domain, and the set of all second values or outputs is called the range. A function is a special type of relation in which each possible input value leads to exactly one output value. And it's got a specific notation that goes with it. The notation y equals f of x defines a function named f. This is read as y is a function of f, or a function of x. The letter x represents the input value, or independent variable. The letter y, or f of x, represents the output value, or dependent variable. So you can have a function or a relation presented in different ways. So if you have a table or a set of points, if we want to determine if the following relations are functions, check to make sure that for every input there is only one output. So for example, to select all the following tables that do represent y as a function of x. In the first table, notice we have x value, -2 only goes to 0, 3 goes to 1, but if you look further down the table, 3 also goes to 13. So if we have the same x value, 3, with two different outputs, then that's not a function. So it's still a relation, but that's not a function. So basically, check and make sure that your x values are unique. In the next set, we have the x occurring twice, so that's not a function. The third, we have -4, 3, 6, 7, 16, so each x value has only one output, so that's a function. And last, all the x values match one output. It's okay if the outputs are the same. It's the inputs. For the variable x equals 1, there's only one output, 3. For the variable 5x, there's only one output, 3. So the second two are functions. So in the table, we could call it a function now, x and y. So this would be x, and this would be, instead of y, f of x. So to use our function notation with the table, if you're asked to find f of 3, that means when x is 3, what is the y value that goes with it? So in the table, f of 3 is equal to 2. So 3 is the input or independent variable, 2 is the output. Then if you're trying to find f of what is equal to 8, you're given the output 8, so you look in the y column or f of x column, and the input variable would be 7. Another way you can be presented with a function is through a graph. And when you're looking at a graph, to make sure that for every input there's one output, we use something called the vertical line test. And that can be used to determine whether a graph represents a function. If we can draw any vertical line that intersects a graph more than once, then the graph does not define a function because a function has only one output for each input. So if you take a look at our first function, if you draw a vertical line anywhere that only hits the function once, the vertical line, remember, is x equals something. So for every x value, there's only one y value. So the first is, yes, a function. The second is a graph of a line. So in this case, every x, there's exactly one y. That's also a function. But when we're graphing a circle, you notice if you draw a vertical line, sometimes you'll hit two values. So for this x value of 1, there are two outputs. So what does that look like in terms of equations? And that's the next thing we're going to look at is, I want to go ahead and just take a look at the circle for a second and the line. So the graph of a straight line is always a function unless it's a vertical line. The graph of a circle is not. If you remember from geometry, the graph of this circle, x squared plus y squared, is equal to the radius squared, 9. If you were to solve this equation in function notation, solve for y, you get y squared is equal to 9 minus x squared square root both sides, we get y is equal to plus or minus the square root of 9 minus x squared. So when we pick an input for x, we're going to get two outputs for y. So that's how it's represented as an equation. And this is what it looks like on the graph, a little bit easier to tell from the graph. So the next definition, we can also be more specific. There's something called a one-to-one function. A one-to-one function means for every input there is one output, so that means it's a function, and for every output there is one input. So once we've determined the graph is a function, a way to determine if it's a one-to-one function is to use the horizontal line test. Draw horizontal lines through the graph, and if the horizontal line intersects the graph more than once, then the graph does not represent a one-to-one. So if we look at the functions above, only the first two were functions. They're both functions, but the first does not pass the horizontal line test. So the first function is not one-to-one. The second function does pass the horizontal line test and the vertical, so that is one-to-one. We're going to use one-to-one functions a little bit later when we talk about inverses. Okay, and the circle's not a function at all, so it can't be one-to-one. All right, now if you have the graph, and just to practice function notation here, if you don't have the equation, you can still find specific values. Just want you to get used to the notation. So if we have f of 2 is equal to something, this is telling us that 2 is the x-coordinate, and we're trying to find the y-coordinate that goes with it. So on the graph, when x is 2, y is equal to 1. So f of 2 is equal to 1, and that represents the coordinate 2, 1. So points are in the form x, f of x. The f of x replaces the y. Other direction, if we are given f of what number is equal to 4, we're given the y-coordinate. So when y is 4, notice there are two x values that have a y. So for what x values do we end up with a y values of 4? So the first one is the coordinate 3, 4. So we get two answers. And the second is negative 1, 4. So that would correspond to the points when x is 3, y is 4. When x is negative 1, y is 4. So that's a function, but not a one-to-one function. All right, so taking a look, the third way you might see a function is in equation form. If you have directions to explain the relationship 2n plus 6p is equal to 12 as a function of p equals f of n, that means to solve the equation for p. So we have 2n plus 6p is equal to 12. Take the 2n to the other side. 6p equals negative 2n plus 12. Divide everything by 6. We get p is equal to negative 1/3 n plus 2. And then now we substitute the function notation. That is the graph of a line, and all lines are functions. So now we can call that f of n is equal to negative 1/3 n plus 2. So the notation just tells us it's a function. It means n, input, independent variable, and then this is the output, dependent variable. All right, so just to practice with function notation a little bit, if f of x equals x squared plus 3x minus 4, then evaluate at different values of x. So when x equals 2, that means substitute a 2 into the function. So f of 2 means we're going to take 2 squared plus 3 times 2 minus 4. So we get 4 plus 6 minus 4, which is 6. So f of 2 is equal to 6. Input is 2, output is 6. The coordinate is the 0.26. Second, you can substitute a variable, f of a. That means substitute a, and you'll get an expression, a squared plus 3a minus 4. you'll get an expression in terms of the variable a instead of the variable x. Third, we can substitute a plus h. F of a plus h means substitute a plus h wherever there's an x. So basically, we can substitute anything we want to. A plus h minus 4. Now, and then simplify. So what we're going to do is we're going to multiply that out and simplify. A plus h squared, remember, is a plus h times a plus h. You'll have a middle term when you FOIL that out. So we're going to get a times a, which is a squared, plus ah again is plus 2ah, and then h times h is plus h squared. Distribute the 3, we get 3 times a plus 3 times h minus 4. So there are no like terms, so that's our expression when we get f of a plus h. All right, last is an expression that's actually something called the difference quotient. And it's something that we're going to work with a bit in this class. So this one looks really complicated. It says take f of a plus h minus f of a divided by h. So it's the first 2 and 3 have kind of led us up to this. So f of a plus h we've worked out over here on the side. So I know that that's a squared plus 2ah plus h squared plus 3a plus 3h minus 4. That's f of a plus h. Substitute that long expression in there directly. Minus f of a. Well, I've got f of a in number 2. F of a is a squared plus 3a minus 4. And then that's all going to be over h. So now what we want to do is just some algebra, simplify. When you multiply through by a negative, very important, all of your values in here, expressions, are going to change sign. So I'm going to keep this a squared plus 2ah, my f of a plus h. Distribute the negative, I end up with minus a squared minus 3a plus 4. And now add like terms. So I have a positive a squared, a negative a squared. They cancel each other out. I have a negative 3a and a positive 3a. They cancel. A negative 4 and a positive 4 cancel. Everything in your minus f of a will cancel with something on the left. And then notice each of the terms that we have left have an h in them. So now I'm going to factor out an h. So if I factor an h, 2ah becomes 2a, plus h squared becomes plus h, factor out an h, plus 3h becomes plus 3. That's still all over h. The h's now cancel each other out, and you're left with 2a plus h plus 3. So it's using function notation and just a longer expression to simplify. All right, the last part of this section are something called basic toolkit functions. So these are a set of functions. It's very helpful to memorize the basic shapes. We're going to use these a little bit later in graphing. So the first function is called the constant function. F of x is equal to a constant or a horizontal line. The next is called the identity function. It's the line y equals x. Next function is absolute value. If you have f of x is equal to the absolute value of x, remember that absolute value takes all of your x values and makes them positive. So we get this V shape. From quadratics, we've got f of x equals x squared. So this is the basic quadratic. These keep extending beyond the points that are graphed, by the way. There's a cubic function, f of x equals x cubed. A reciprocal function, 1 over x, the reciprocal of x, has a hyperbola with two different branches with a horizontal vertical asymptote at 0. There's a reciprocal function squared 1 over x squared. Again, that has a vertical asymptote. The square root function, when you put in values in the domain x, and x has to be greater than or equal to 0, and then a cube root function. So these are some of the basic functions that we'll be working with in the course.